it will be filtered by PC3, and it will be filtered by PC4. Okay, but and we will have this VIN line a completely clean straight line. Okay, this is not a active filter. Okay, this is called a passive filter. Okay, why? Because it only will work when some AC component is present. Okay, that is why it is here. The charger itself has a filter right here. Okay, this inductor, it's here to filter. Okay, but by some mistake, some fault, some error, okay, if this AC components, okay, get through the charger, get through the inductor, okay, the computer, the motherboard itself, it will have this filter at this point. Okay, at this point right here. So, and we will have this VIN voltage, a straight line on our oscilloscope. Okay, if you measure here with your oscilloscope and you see some noises, okay, we call noises the electrical noises. Okay, it's when you measure and you see some peaks, okay, some distortions, okay, distortions online. Okay, you see something like this. Okay, this is called dirt, this is called noise. Okay, this is called noise. Okay, or it is called a smooth ripple. Okay, better, or it is called a smooth ripple. Okay, a smooth ripple, it's a straight and clean line. Okay, this is called noise, this is called noise, this is called dirt. Okay, this is called dirt. Okay, and when you measure it, we are here when it says VIN, you need to have a straight and clean 18 volts DC presented on your oscilloscope. Okay, right here. So next, VIN voltage, this VIN voltage right here. Okay, it will be taken to this point of the schematic. Okay, this point of the schematic, VIN voltage right here. Okay, so this VIN voltage, it will go through PR40, PR33 and PC4. Okay, then I will come back here on pin 3 and pin 5. Okay, power good, it is not connected. Okay, so I will not worry about him. Okay, and then I know how this works. Okay, continuing. So after we have 1.8 volts working, okay, you see here, after we have 1.8 volts working, okay, now Adrian, now that you already learned, okay, how to read a schematic and how to read a IC regulator pin by pin, okay, I will ask you, okay, what is the first pins that I need to look? Answer me that question while I'm going to drink some water. Okay, I just need to know the first pin I need to measure. Okay, not the second, not the third, the first pin. Okay, okay, pin number 2. Okay, sorry, second pin. What is the second pin? Yes, yes, you see. Okay, when you understand, okay, the sequence of a IC regulator, okay, you can tell just by looking at the schematic all the sequence, all the pins you need, to look for. Okay, this is how you will learn. Okay, not by forums or whatever. Okay, it's grab the schematic and study, practice, practice, and practice. Okay, so first pin, pin 5, second pin, pin 6. Okay, tell me the third pin. Do not have the necessity, okay, of feeling the feeling, okay, not feeling from feel, okay, but feeling from full, okay, a feeling the schematic, okay, with lots and lots of information. Okay, let's just see. I'm writing man right here. This is man. Okay, this is man. Okay, but in here, okay, I only need a man. Okay, but in the second page I need a woman. Okay, so I will not put a woman. Okay, I will write man, and I will say that it's the inverted of man. Okay, it's the inversion. Okay, it's the inverted of man. Okay, it's the opposite of man. Okay, I have back. Okay, let me just B and K. Okay, meaning my back. Okay, and I want to write belly. Okay, I I will not, okay, fill my schematic with back, belly, man, woman, head, feet. Okay, I have not necessity for that. Okay, I just need all. Look, I have back. Okay, and I have the opposite of back. Okay, and you need to know, okay, and you need to study, because the schematics are made from engineer to engineer. Okay, and you need to understand that when I said my back inverted, okay, I'm not meaning my real back. Okay, I'm meaning the opposite of my back. Okay, I'm meaning my belly. Okay, when I say my back hurts, okay, when I say the opposite of my back hurts, you need to know that I'm referring to my belly. Okay, it's right here. I can describe this signal. Let me just find my pen. Okay, I can describe my signal as 0 or the inversion, okay, of the input. Okay, I mean the inversion of input with this trace above the numbers 3.3 volts. Okay, right here. So let's continue. Okay, we are just watching, okay, our NOT or inverter gate. Okay, it's here, our NOT gate or inverter gate. Okay, because the function, this his function, sorry, because his function is to sorry, inverter, okay, that it will inverter, no, okay, converter, okay, converter, regulator, it's better, okay, it's a internal regulator, okay, that it will regulate 19 volts to 5 volts. Okay, that's why it's called a low drop out. Okay, because it will grab this high voltage of 19 volts and it will drop to a voltage, okay, to a small voltage, okay, to a lower voltage, 19 to 5 volts. Okay, so this 5 volts linear, right, VL or low dropout LDO or linear dropout LDO, it will goes, okay, to pin 19 as being PVCC. Okay, after this, okay, when this signal, when this ICPU3 receives the voltage input VIN, okay, on pin 6, on pin 4 it will receive this signal VS, okay, voltage supply, in shape of enable underscore LDO right here. Okay, when this VS signal, okay, it is created by this VIN voltage that it will pass through PD4, okay, and PR10 and PR11 right here. Okay, right here. So this is page 39 of the schematic. Okay, and we see where this VS voltage is created, is generated right here. Okay, so we can see that this VS voltage starts or have is or is generated by VIN voltage. Okay, so as you can see right here, we have 19 volts. Okay, 19 volts. Let's, because this diode here, it will create a drop voltage of 0.7 ups 7 volts. Okay, this diode right here, okay, it will take out 0.7 volts from VIN. Okay, so here we have 19 volts, but here, okay, we will have 18 dot this OR gate. It will sum 0 plus 1 equals 1. Okay, and here you will have 3 volts. Okay, third, input pin 1, input pin 2, 0. Okay, 1 plus 0 equals 1. Input pin 1 plus input pin 2, okay, 1 equals to 1. Okay, binary numbers, we don't have 2. Okay, 1 plus 1, it's 1, not 2. Okay, 1 plus 1 equals to 1. Okay, so we have 1 logic, 1 plus 1 equals 1. Okay, or 3 volts plus 3 volts equals to the output of 3 volts. Okay, quite simple. Okay, there is no difficult in here. Okay, it will sum his values. Okay, now let's go back to our schematic. Okay, after all these